Good day, everyone. It is nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel. In this particular video of our course mathematics for SS3, we'll be dealing with algebraic processes and calculus in our practice drills videos. So now the first exercise will be exercise 4, and in this example 4 we are asked to simplify 2 open bracket h minus 3 open bracket k minus h close bracket minus 3 open bracket k minus 2 open bracket h minus k close bracket. Now in this particular question, what we are going to do is, the first thing you are going to do is you are going to open the brackets up. So when you are opening up the brackets, all you need to do is you are going to multiply the brackets by the coefficients outside them, or if there's no coefficient, you are going to simplify the terms inside the bracket. For example, in the first bracket, what we're doing here is we are going to multiply in the second bracket, we multiply each of the terms by 3. So when we expand that, we'll now expand the second bracket also, multiply each of the terms by minus 2. And then after that, we are going to expand the bracket. Then after expansion, at the end of the day, we have 2h minus 6k plus 6h minus 3k plus 6h minus 6k. So the next thing to do is to collect the like terms. So what this means is you are going to collect the h's together and you are going to collect the k's together. So the h's together and the k's together. Now the h's together, we have 2h plus 6h plus 6h. Then the k's together, we have minus 6k minus 3k minus 6k. At the end of the day, we have 14h minus 15k. So that is the end of this example. Now let's move on to the next example we have on and this first example, which was on collecting like terms. So this is collecting like terms. Then let's move on another example on factorization. Now in this factorization example, we are going to deal with factorize x minus a. It is a new expression, so we are asked to factorize x minus a times 3x plus 2a minus x minus a squared. So x minus a is a common factor of two parts of the expression, as you can see. So all we need to do is we are going to factorize that out. So when we factorize that out, that will give us x minus a open bracket 3x plus 2a minus x minus a squared. So that will be x minus a. When we factorize that, open bracket 3x plus 2a minus x minus a close brackets. At the end of the day, we have x minus a open bracket 3x plus 2a minus x plus a. Then we have x minus a open bracket 2x plus 3a. So those are the two expressions you factorize. We've been able to factorize that into two expressions. So let's move on to the next question, and this next question will be on factorization too. So now here we have to factorize am plus 3bn minus an minus 3bm. So as you can see in the screen, this question on the screen, you have the terms am and an have a in common. So the terms bm and 3bn have 3b in common. So you are going to collect the common like terms. So that is just what it means. And then when we collect the like terms, in the first two, you are going to group the first two, and then you group the last two, as you can see. So am plus 3bn minus an minus 3bm. So then we have am minus an minus 3bm minus 3n. We have collected the like terms. Then next we'll factorize what is common. In the first two terms, a is common, so that will be a open bracket m minus n. In the second two terms, minus 3b is common, so that will be minus 3b open bracket m minus n. That will be, when we factorize what is common again, you can see that in these two group of expressions, m minus n is still common. So that is these two expressions, we are going to factorize m minus n. When we factorize m minus n, we have m minus n multiplying a minus 3b. So that is the solution of this particular question. So hopefully you understand this, and let's move on to the next example. And this next example will be based on another algebraic process which we often talked about in the previous episode of this video. And this next example will be based on our simplification. So now let's talk about simplification. Now in this exercise, let's we have to simplify x over x minus 3 minus x minus 1 over x plus 2. So now this is clearly a group of two fractions, and these fractions have their numerator and denominators as terms in variables. So what we're going to do is still the same normal method. We are going to look for the common like terms. So now, sorry, we are going to collect the like terms. So that will be x over x minus 3 minus x minus 1 over x plus. So that will be, now when we look at the denominator, that will be x. We'll collect the, we'll look for the LCM. So that will be the multiplication of those two terms of the denominator. That will be x minus 3 plus times x minus 2. So next we are going to how many times can we see x minus 3 in the product of x minus 3 and x minus 2? So that is clearly x plus 2. So x plus 2 times x in the first case, and then we have minus x minus 1 times x minus 3 in the second case. So that is the numerator, and then when we expand the numerator, we have these terms: x squared plus 2x minus x squared plus 4x minus 3. Then the denominator still remains the same. We don't expand it. The denominator is still open bracket x minus 3 close bracket open bracket x plus 2. Then next, when we simplify the numerator, we have 6x minus 3 divided by x minus 3 open bracket x plus 2. So then when we factorize again, we have 3 open brackets 2x minus 1, and then the denominator remains the same. So that is, the denominator remains the same because there's nothing we can use to factorize in the denominator. So it's just the same like that. So let's move on to the next part of this question. So in this next part of this question, let's deal with another. In this part, we will talk about substitution. So now in this case, we are going to be substituting values. So this, let's give our, this is example 26, and here we have to evaluate ab squared minus c squared over 2bc plus a squared over 2b plus c. So in this case, we have a is given as 2, and b is given as minus 3, and c is given as minus 2. Now in this particular question, what we are going to do is we are going to have that this ab squared minus c squared, we are going to substitute our corresponding values of a, values of b, and values of c in the equation. So in this case, we are going to substitute our a as 2, we'll substitute b as minus 3, we'll substitute c as minus 2. So here when we substitute, that will be 2 open bracket minus 3 squared minus 2 squared divided by 2 times minus 3 times minus 2, then plus 2 squared in the numerator of the second fraction divided by 2 open brackets minus 3 close bracket plus open bracket minus 2 close bracket. So when we evaluate all that, the first fraction we evaluated as 2 times 19 minus 4 over 12. The second fraction is evaluated as 4 divided by minus 6 minus 2. And then that will be, when we evaluate it, that will be 14 over 12 plus 4 over minus 8, and that will be 7 over 6 minus 1 over 2. At the end of the day, our answer will be equals to 2 over 3. So that's the total value of this fraction. And for your information, this question was solved based on the method of substitution. So this substitution, we make it of substitution of the values of a, b, and c to calculate the fraction. And this is another algebraic process you need to master. So let's move on to the next part of this video. So we are dealing with some examples, and this is a practice exercise videos. So that is why we are doing these examples. So we are brushing off what we've covered in the SS1, SS2, and SS3 section of this course. Let's move on to the next part, and this is example 35. Now in this example, we are going to be dealing with partial variation. Now this partial variation is the variation that where we have when something is varying, both constant and also varying. When a quantity is both constant and both varying. So now in this question, let's say c is partly constant and partly varies as m. If c is 45 when m is 10 and c is 87 when m is 24, a, find the equation connecting c and m, and b, find c when m is equals to 18. Now in this particular question, what we are going to be doing here is, let's start from a. Now what we are going to do here is we want to look for the equation connecting c and m. So generally anytime you are given a partial variation question, you should know generally that c equals a plus k m, where a and k are constants. So but that's your c is what is partly constant and partly varying, and then that's your m, it is what is it is varying as. So it is varying as your m, which is 10 when c is 45, and then your c is 87 when m is 24. So all you need to do is you are going to you are substituting your two instances of such conditions, and then it will leave you with two simultaneous equations, just as you can see. So in the first equation, we have 45 is equals to a plus 10k, and the second equation we have 87 equals a plus 24k. So when we subtract equation 1 from 2, we have 42 equals 14k. So and then when we divide both sides by 14, we have k equals 42 over 14. That's k equals 3. Now then next we substitute 3 for k in equation 1, and to find we use that substitution to find a. So when we substitute, we will get 45 equals a plus 30, because where we in the equation 1 we have 10k, so 10k will be equals to 30 because k is 3. So then when we collect like terms, we have a equals 15, and that is the value of a. So hence we will now substitute our values of a and k, which are 15 and 3 respectively, into our original equation. So our original equation is c equals a plus km. So when we substitute values of a and k, we will get c equals 15 plus 3m. Now that equation is the law connecting those two variables c and m. Now that is for question A. Now let's move on to sub question B, which is find c when m is 18. Now in this particular question, all you need to do is you are going to do a substitution. You are going to substitute the values of m, which is 18, in the equation, and then you are going to calculate the corresponding value of c. So in this case, that's c will be equal to 15 plus 3 times 18. So that was 15 plus 54, that's 69. So that is the corresponding value of c when you have your m as 18. So this is the equation. This is a question that verifies, that shows you how to make use of partial variation. Now let's move on to the next part of this video, which is calculus. Now in this particular section of this video, I will be dealing with the question myself. I'll be solving it myself, so I want you to pay complete attention to this question. And this particular question, you will remember in the previous videos, if you watch the previous videos of this course, I talked about calculus, and I said calculus can be applied in various ways. So you can apply calculus in looking for the gradient and the also the area and the volume of a curve. But in this case, we are going to be dealing with the gradient, and I'll be teaching you how to approach questions like this. Now this question on calculus is solved as such as follows. So pay attention. Now the question is this. So I don't know, I'll also give the question on the screen. So the question will be on the screen now. So now we have our the gradient of a curve is given by dy dx equals kx raised to power minus 2. Now where k is a constant, so you should be able to see the question on the screen now. So now k is a constant. If the curve passes through the points 4,7 and 6,8, find a, the value of k, b, the coordinates of the points on the curve where the gradient is 3. So hopefully, if you can see the question on the screen, you don't have issues with that. You can also read the question again, and you can also try. If you can pause the video and try it yourself before I try it. Now, but in this question, we have the gradient of the curve is given by dy dx. So we have dy dx equals kx raised to power minus 2. Kx raised to power minus 2. And then here again, we also have that k is a constant. So k is a particular constant here. Then if the curve passes through the points 4,7 and 6,8, so we have 4,7 and 6,8 and 6,8. So here we're asked to number A, we are finding the value of k. Now let's look for number A first. Then next we are going to look for the coordinates of the points on the curve where the gradient is 3. Now looking for number A, before we can look for k, we will need to look for the equation of the curve. Now we are told that the curve is given by dy dx equals kx raised to power minus 2. Now if this is the equation of the curve, then let's integrate the this value. So when we integrate this value, we are going to get the value of the curve, the equation of the curve. So when you integrate the gradient of a curve, you are going to get the value of the equation of the curve. So that means if dy dx is this, then y equals y will be equal to the integrand of the y dx. So that will be integrand of kx squared x raised to power minus 2 with respect to x. So this is the approach of the question. Now when we integrate this, we can also bring the constant out, because the constant does not affect our result. So y equals k integrand of x raised to power minus 2 dx. Then next we have what? Y equals k times what? When we integrate this, we will have the process of integration is carried out when you have x raised to a particular power. You are going to increase the power by 1, so that will be x raised to power minus 2 plus 1. Then you are now going to divide by your result. Divided by your result, when you minus 2 plus 1, let's write it down. That will be our result. That will be k times x raised to power minus 2 plus 1 divided by minus 2 plus 1. Then you add your constant of integration, which is c. It's your arbitrary constant of integration. Now when you solve this, you have our what? You have k x raised to power minus 1 over minus 2 plus 1 is minus 1 plus c. That will be equals to what? K, that will be minus k, because minus 1 is here, so that will be minus k, and x raised to power minus 1 is 1 over x. That's minus k over x plus c. So this is the value of the curve. This is how this general equation of the curve, but we don't know the particular value of the constant. So now we have y equals minus kx over c. Now let's substitute our value. They said we have when x is 4, y is 7, because it passes through the point 4,7, and when x is 6, y is 8. So now let's substitute the values. So when you have y equals minus kx plus c, right? So when x is 4, y is 7. So 7 equals what? Minus k over x is 7, x is 4 rather, plus c. Let's call that equation 1. Then we have equation 2 as when x is 6, y is 8. So that means 8 equals minus k over 6 plus c. So this is our equation 2. Now we can see, let's convert this equation into a form that we can easily mess around with. So now let's multiply. In this first equation, let's multiply both sides by 4. So that will be 28 equals minus k plus 4c. That's equation 1. And then our second equation, we also have when we multiply our second equation through by 6, we have 8 times 6, that's 48. 48 equals minus k plus 1 multiplied through by 6, that's plus 6c. That will be equation 2. Now let's perform an operation. Let's subtract equation 1 from equation 2. So that will be 28. When we subtract 28 from 48, we'll get 20 as an answer. As 20 equals, when we subtract minus k from minus k, that's 0, equals 0. When we subtract 4c from 60, that's 2c plus 2c. That means 20 equals 2c, right? So that means let's divide both sides by 2. That will be 10 equals c. That means our value of c is 10. So let's substitute our value of c into equation 1 to get the value of k. That means 7 okay, into equation 1. Okay, that's 28. 28 equals minus k plus 4c. So but c is 10, right? So 4c will be what? 40. So let's collect the like term. So 28 minus 40 equals minus k. And then at the end of the day, so minus 12 equals minus k. So at the end of the day, we have k equals 12. When we multiply both sides by minus 1. So that's the value of k. So c is our c is 10 and our k is 12. So we can rewrite the equation of the curve of the curve as y equals what? Since y equals minus kx over c, that means y equals minus k over x plus c. That's y equals minus k is what? 12 minus 12 over x plus c is what? Our c is given as 10 plus 10. So this is the equation of the curve that we're given. And then let's move on to number b. This was number a. This is number a. So let's move on to number b. And this particular number b, we are asked to find the coordinates of the points on the curve where the gradient is 3. So now we have to divide the x equals k x is power minus 2. So that means your k is what? That's divide the x equals divide the x equals kx, but k is 12, right? That's 12x is power minus 2. And we are given that we are looking for the points where the gradient is 3. So the gradient is still the same thing as divide the x. So and it is the gradient that is the value of divide the x at when divide the x is 3. Now let's equate that. If 12x is power minus 3 is 3, that means dividing both sides by 12, that means x is power minus 2 is what? 3 over 12, that's 1 over 4. So that means x is power minus 2 equals 2 raised to power minus 2, and as a result x equals 2 by equating both sides. So that means x is 2, we've gotten the x coordinate. Now what is remaining is for us to look for the y coordinate. So we're going to make use of the equation of the curve, which is y equals minus 12 over x plus 10. So when x is 2, so y equals what? Y equals minus 12 over 2 plus 10. That means y equals what? Minus 12 over 2, that's minus 6 plus 10. So minus 6 plus 10 is 4. So that means the coordinates at which the y the x is 3. That will be what? X comma y is 2 comma 4. So this is the required coordinates. So that means for your number A, you have your equation of the curve as y equals minus 12 over x plus 10. For your number B, you have the coordinates as 2 comma 4. Now hopefully I hope you've been able to gain something from this video. So but till we meet again next episode, thank you for watching.